An object goes from one point in space to another. After it arrives at its destination, its displacement is this compared to the distance it traveled, right? Either greater than or equal to the distance it traveled, always greater than the distance traveled, always equal to the distance traveled. Okay, so read this over. Come up with your best response. Okay, we ready? Go ahead and give me the... We'll vote again now. I see some of you have changed. Looks like most of us are at 4s now. Is that right? So the displacement, it's asking about the displacement versus the distance traveled. The displacement is from the beginning point to the end point, right? That's the straight line distance from the beginning. That's always the smallest possible path you can take between the two. So it's either less than or equal to the distance traveled. The distance traveled could be huge, right? You could be all over the place and getting from the beginning to the location to the ending location. Okay, we good with that one? All right, then let's try this one. Oops. Smaller or equal, number 4. Right, you could take the straight line path from A to B, and then your displacement and your distance traveled are the same. Or you can take the curved path from A to B, and your distance traveled is much greater than the straight line path, which is the displacement. We've got our runner running 15 km per hour. Our runner is 7.5 kilometers from... Oh, I hit a button here, didn't I? 7.5 kilometers from the finish line, and a bird joins the runner. The bird's moving twice as fast. And what does the bird do? The bird just mocks the runner by flying to the finish line, turning around, flying back to the runner. Flying back to the finish line, turning around, flying back to the runner. And it keeps flying back and forth between the runner and the finish line as the runner moves. Oops, this is too sensitive. Okay, and we want to know how far does the bird travel? How many kilometers? The runner takes a half hour for the runner to get to the finish line, right? Yeah. The bird's going 30 km per hour for a half hour, 15 kilometers. Okay? This is an easy one to overthink. Well, we're just saying it's going at a steady 30 kilometers per hour. So it does a quick turnaround. We don't worry about that. We just say it's moving basically at 30 km per hour for the entire time that the runner is moving at 15 km per hour. And they both go for the same amount of time, so the bird's going to cover twice as much distance. We're good so far. We're talking displacement, we're talking distance traveled, we're talking speed and velocity. The next thing, of course, acceleration. So acceleration, another one of those terms that we use very, very specifically in physics, and we use kind of loosely in everyday language. Acceleration means change in velocity. So a change in velocity over a change in time, right? That would be our average acceleration. Acceleration is also a vector. Okay, so that means that we have acceleration whenever the velocity is changing. How might the velocity change? Yeah, you might speed up, right? Your speed may increase. If your speed increases, then your velocity is changing. We have acceleration. It may also decrease, right? The speed may decrease. If this velocity changes, we have acceleration, right? So in physics class, we would just say either one of those is acceleration. The car speeding up, the car slowing down, it's all acceleration. In everyday usage, we tend to use the term acceleration to mean speeding up and deceleration to mean slowing down, right? It's best if we try not to use deceleration in this class. It's a confusing term, but we'll try not to use it. Sometimes I slip up and I use it anyway. But acceleration means the velocity is changing. The speed is increasing, the speed is decreasing, and actually, there's another way the velocity could be changing. The speed might not be changing at all, but the direction might be changing because velocity is a vector quantity. It has both magnitude and direction. So the magnitude, right, the speed could be changing, or the direction could be changing. So a car driving around at constant speed in a circular path has acceleration, is undergoing acceleration because the velocity vector is always changing. The direction of the velocity vector is always changing. So there has to be acceleration. So in our case, acceleration just means that the velocity vector is changing. It could be increasing in speed, decreasing in speed, or the speed might be the same. It could be changing direction. Introduce the concept of motion diagrams. So a motion diagram is sort of like a strobe photography of an object moving. So we can see where the object is at certain points in time. And the key to the motion diagram is that these these dots that we're going to use to represent the position are always equal time intervals apart. So if we're in a dark room and our object is moving across the room and a strobe light goes off, we see the object right here. Then the strobe light goes off for a certain period of time, it comes back on, and the object is now over here. The strobe light goes off for a certain amount of time, flashes, and we see the object over here. And remember, these flashes have to be at equal time intervals. The fourth flash, we see it over here. The fifth flash over here, okay? So, what do we know about this object? It's moving with constant speed, and we know that because we know those dots are equal time intervals apart, and they're also equal distance apart. So the distance that this object travels in every time interval is the same. It's not changing. So this is an object moving at constant speed. Okay, we could also do this. The first one goes here. Then the next time the light flashes, the object is here. The next time the light flashes, it's there. Then it's there. And it's there. So what's happening with this object? There's acceleration for sure, and there's acceleration because its speed is increasing, right? And I think if I drew it correctly, it's increasing at a constant rate. The acceleration is constant. Each one of those time intervals increases by the same amount. So this object is moving with increasing, oops,